imagine that inside here, I have a function called sqrt, square root of x. And I don't actually, we saw, I think I did a function that computed square roots earlier. I'm not going to repeat that, but let's say I've got a function sqrt that computes square roots of real numbers greater than or equal to 0. Okay? And so imagine that its definition is here. All right, so now what happens is we'll go like so. First thing we'll ask is if x is less than 0. And, okay, and remember in OCaml doesn't convert integers to reals automatically, so I have to be careful to tell the difference between reals. I have to say 0.0. Okay, well look, if x is less than 0.0, then it's a negative number. There are no real results, so I'm never going to call the continuation. So I will return the unit object instead. I have to return something. OCaml demands that every function return something or other. But here it's going to just return just this dummy value. Okay. Well, now if we get here, we know that my pencil set's working. Hold on. Well, let's go with this and see what happens. Bad news. No, I've got one. It's just slow. There we go. Let's try this. Else. Okay, at this point we know that the square root of x, or that x is greater than or equal to 0. So let's say we're going to compute a new square root. Let's say it's r for root. And so here we'll call sqrt of x. Okay. Well, let's not do that just yet. Sorry about that. Okay, well, another possibility is x could be greater than 0. Okay, if it is, then what happens? Now we'll compute the square root. So we'll say sqrt of x in. All right, and now we know that there are two square roots, r and minus r. So we will call the continuation twice. We'll call it with etc of r, and we'll call it etc of minus r. Okay, and this semicolon operator here, this is something that you haven't seen, that I haven't talked about in lecture before. Semicolon operator lets you compute a series of values and then return the last one. So if the e's here are expressions, and I write E1 semicolon E2 all the way out to En, what happens is that it executes first E1, then E2, then E3, and so on, then out to En, finally returns the value of the last one. Okay? Now, you have to be kind of careful with semicolons if you're used to languages that use notation like C does, because in OCaml, semicolon is an operator. In the C's, it's a delimiter. It tells where an expression stops. So you can't write an extra semicolon at the end. If you do that, OCaml will start to cry. And you don't want that. Okay? So the idea here is that this just is executing a series of things in sequence. Okay, so what's happening here? First thing we'll do is we'll call etc of r, and we'll call etc of minus r. We effectively then have a function that has produced two different values. All right? And the third possibility, Well, if it's not less, if it's not greater, it must be equal to 0. Then we'll just say ETC of 0.0. Okay, we don't even need to call our internal helper. All right, so the way you'd call this is you'd say something like SQR, and I don't know, maybe there's a number A that you want the square root of. And note, an SQR does not return a useful value. Functions that use continuation passing might return useful values, but they might not. What they're really doing is they're really providing values to their continuation. So what you might do is write something like so. SQR of A, and then here, you've got an anonymous function. We talked about those last time. I hope we did. Where here you've got a function that takes a parameter R, and then it does something with it, indicated by the 3 dots. I don't know what the 3 dots are, but the idea here then is that if A is 0, the continuation is called once with R equals 0. A is greater than 0, the continuation is called twice with minus square root of A and square root of A. And if A is less than 0, the continuation isn't called at all, and the computation simply stops at that point. I suppose you could arrange to produce some kind of error message if you wanted to. All right, and just one more thing, and then we'll try to deal with questions here. What's the type of this? Okay, if you were to type this into OCaml, well, what happens is that the type, okay, we take a float in X, and then its second argument is a function that takes another float and returns unit, okay, and the absence of a value, and then SQR itself then returns the unit type. Unit type is just the type of this thing, it needs a dummy value. Okay? So that's, the idea here is that this is just a really simple example of continuation passing. Probably nobody would really do this, but in a minute we'll get to an example that maybe somebody will do. Okay, questions about that? Does that make sense? Go ahead.
What does the ETC minus R do?
So I'm taking R minus changes its sign, so I get negative R, and then I'm calling ETC with negative R.
Is this just part of the square root algorithm you're using?
Well, the square root algorithm is actually inside here, which I didn't show you because I think I already did one at one point. I didn't want to write it again. So there really is a square root algorithm inside here that is that works for x greater than or equal to 0. Go ahead.
What would the continuation be then?
The continuation here is ETC. The square root function doesn't have a continuation. It's just an ordinary function that returns a value. Do you want to ask me something else?
What would you ever pass as ETC if you were calling SQR?
It works like this. So here is x. That's the thing you want the square root of. This function, anonymous function, is the continuation. And then here, inside the anonymous function, is some code that does something with the square root of x. Square root of a in this case. I don't know what it does. Does that make sense? Kind of. Maybe a later example will clear things up. Other questions? Go ahead.
So I have 2 questions. The first is, when you call this function, the parent function of the message.
Okay, so let's make sure we know.
SQR.
So when I call SQR, okay.
So what is the value that's returned as a result of that?
Unit object. Okay, so that's actually a good question because functions that work by continuation passing don't necessarily have to return useful values. They might, but they don't necessarily have to. All the action is taking place when we call the continuation.
Okay, and the second question is, that line that says NBTC or semicolon UTC minus R.
Yeah.
So,
So what that means is first call the continuation ETC with R, then throw the value away that it returns, and then call ETC with minus R, and then return the result of calling ETC minus R.
okay,
So that's what the semicolon operator does. It executes expressions in order, it throws away the values of all but the last, and then it returns the last.
so what's the purpose of calling that first, ETC R if we're just gonna throw it away?
Because we're throwing away the returned value, but we're using the value that we're passing to the continuation. So this function here is the continuation. And so that is going to get R initially, and then it will do something with it. We don't know what, but it'll do something. Then it will get minus R. Gets minus R here, it does something with minus R. Okay, so it's important to distinguish between the value returned by a function and the value that is provided to its continuation.
Right.
That make sense?
Yeah, but nothing can really happen that changes R, right?
No, you can't, because, well, what do you mean by change? I mean, we don't have variables yet, we don't have mutable objects.
Right.
But we do have this function getting called twice, one with the square root and one with the negative square root. That make sense? Okay, other questions? In the back, go ahead.
I just want to clarify, so like if ETC was like a print, it would print like the square root and then like the positive and the negative square root.
Yeah, exactly.
That's what you would use this for.
Yes, so if I said, for example, square root of 4.0, and I would then, and the continuation printed things, then I would see 2.0 and minus 2.0 printed in that order. Do you have another question?
Yeah, I was meaning to ask if the function square root, we don't actually need for it to be printed out at all, right? Now we are trying to pass it to the continuation function which we want to do most of the work.
No, we don't need to print it at all. The continuation is presumably going to do something with it. So, I don't know, what do you do with the square root? I don't know, maybe you use it to compute distance between 2 points. Okay, so once the, well, then you'd have to have you'd have to define what a negative distance is, so the analogy sort of breaks down. But the idea is that this continuation function is doing something with the square root. It's continuing the computation in some way. Go ahead.
So basically this is an alternative to using a list because we are not interested in the values alone, we just want to do something with the values. So this just passes it to the continuation function where the value is processed, and this doesn't need to return anything. The SQ
Right. You have got it.
Okay.
So we, for example, we could have passed the positive and negative square roots as a list, and then and done something like that, but we actually don't need to. We're computing these values one at a time. Other questions? Are you good so far?
Yeah.
Okay, other questions elsewhere? All right, let's try a more realistic example. So the example I started off with here is one that says, let's say we want to produce a series of values, and square root wasn't very interesting for that because it only produced either no values, one value, or two values. What happens if we've got a function where we want to produce lots of values? Okay, so I'm going to write here a function that I'm going to call for_int. Okay, so for is because this is going to act something like a for loop. in an imperative programming language, okay? And ints, because it's gonna produce a series of integers. So here's my continuation, etc. And let us say here are two integers, min and max, okay? And to keep things simple, I'm gonna assume that min is less than or equal to max. Okay, so what is this gonna do? This is gonna call my continuation on integers starting at min and ending at max inclusive. So if I was to call this function on with min and max, let's say 1 and 10, it would call the continuation on 1, then on 2, then on 3, then on 4, and so on, all the way up to 10. In other words, that's the same kind of thing that a for loop might do in an imperative language like C. Okay, so I'm going to have an internal helper here, which I'm going to call for inting. Again, I'm abusing English a little bit here, but I want to keep my ing convention for helper functions. And this is the function that does all the work. And let's say it takes a parameter that I'm going to call which, because that's going to tell me which integer I am going to call my continuation on. Okay? And by the way, this could be an internal helper because min and max are never going to change. etc is never going to change. I can just inherit those. I don't have to keep passing them around. Okay, so I'll go like this. So I'll say if which is less than or equal to max. Okay, then, and here's an unfortunate inconsistency in OCaml syntax, one of many, and that is that if I want to use semicolons with an if-then-else, I have to enclose the thing with the semicolons in it in parentheses. Note that I did not have to do that elsewhere. Okay, OCaml syntax is not consistent. Take it up with the designers of the language. Okay, so what do I want to do? So which is the number I'm currently looking at. So I want to call my continuation etc with which, and then I want to call for inting with which plus 1. And note, that is a tail recursion. I haven't finished writing this yet, but that's a tail recursion, so that means that this is as efficient as a loop, as an iterative loop. Okay, and all right, what happens if which is not less than or equal to max? Well, if which is greater than max, that means that I have to stop. But in OCaml, I always, if I do an if-then-else, I always have to have an else. And so I'm going to have this again return the unit object. All right, and here this in matches this left. So I'm going to say for inting, and I'm going to start that with min. Okay, and there we go. So what's happening here? For inting initially gets called, so which is initially min. If which is less than or equal to max, I'm going to send that to the continuation. Okay, then the semicolon here means sort of forget about what this just did and continue the recursion with which plus 1. So as I continue around the continuation, I'm going to compute min plus 1, then min plus 2, min plus 3, min plus 4, and so on, until finally I get to max. Or, put another way, let's say I was to write here 4 ints, and here's my continuation. Let's say j, and let's say what I want to do is print. Say I want to print j. I haven't talked about I/O very much, but you've seen I haven't talked about I/O very much, but you've seen it in, some of the lab assignments. There's a function called printf, that you can get by loading a package, and it takes a format string and then something to print. So what this is saying is %i, this is saying print j as an integer, and then the /n is saying, go to the next line after that. Okay, so maybe I could go something like this. I could say for ints, here's my continuation. Gonna start at 1 and going to go to 10, and what this would print is 1, 2, 3, 4, all the way up to 10. And then it would stop. And this works like a counting loop, or a for loop in an imperative language. Okay, so what's this telling us? This is saying, well, if we have continuation passing, we don't actually need a for loop. We can write our own. Go ahead.
Isn't the etc which semicolon where it just kind of executes the function and then forgets it? Isn't that a very imperative thing to do when you put in a function?
No, imperative stuff. Well, okay, so granted, this is sort of simulating imperative actions, right? Used in an applicative way. So in that sense, you're right. But I would disagree, because usually what happens in imperative languages is we're changing stuff. We've got variables or mutable objects that we're changing. But we're not doing that at all at this point. We're simply doing a computation and then forgetting about it and then going on to do the next computation. Okay, so any comments about that? No? Okay, go ahead.
So the first etc which line, basically that just checks it where the end.
So etc which the thing that's testing at the end is if which is less than or equal to max. Okay, that means we're not at the end. So then we can go call the continuation to provide which, and then we will do a recursion to go on to get the next value again.
Now.
No?
No.
I hope. Okay.
So if you don't keep any value when you return from the first, I'm just struggling to see that.
Well, okay, let's think about the way a for loop works. In C, for example, or C++. Hold on just a second. Or, any language that has that. Those aren't keeping values around. And we can do stuff with those. Also, we can modify this a little bit so that the continuation can actually return a value. And then we can use that value. So I want to try to build this up a little at a time. And so I'm not quite there yet. But either today or next time, we may get to the point of seeing a function that actually uses the value returned by its continuation. And somebody has a question in the back. Go ahead.
So when you see that, if it says which less than equal max, then the etc basically is like return this value and then run it again with the larger.
Yeah. So etc which calls the continuation with which. Continuation does something with it. Okay. For ints doesn't care what it does. And then it goes on to get the next value. That's what the recursion does. Okay? Did that answer your question?
Yeah.
All right, other questions? Yes, go ahead.
I have some questions. So which is a function and max, right?
Which is a parameter name. So up here I'm saying let rec for inting which. So which is the name of for inting's parameter. etc is a function. So I'm calling etc with whatever the current value of which is.
Then what's the type of
The type of for int, so I don't know, let's figure it out. So, let's see, so this is taking a function ETC is a function that takes an integer and returns, let's see, what does ETC have to return? It doesn't matter what it returns, because this value is always getting thrown away. Okay, then ETC, then for int takes an int, which is just min, and then it takes another int, which is max, and then what does it return? Well, here at the end, it always returns the unit object, so it's going to go like that. So its type, I hope I've got that right. Its type is going to be this, and this quote A here, this is just a parameter that ranges over an arbitrary type. It's saying we don't actually care what ETC returns, because it appears here and we're not using its return value for anything. I hope I've got that right. Does that make sense? Other questions? Okay. Now, one of the, oh, I'm sorry, go ahead.
I just wanted to make sure that the first line I understood properly. So you sort of, ETC is just supposed to be whatever function you want to repeat multiple times. Okay, so it could be any function, it just needs to be whatever function that you want.
It can be any function that takes one argument.
Okay.
It doesn't even matter what value is returned by it. Okay, it could be any function any function that takes one argument.
Could you sort of do a nested ETC, sort of like a nested loop?
I'm actually going to do that next. So hold on, you're about a minute ahead of me. But before I do that, other questions? Go ahead.
So, it's like when you add like that, the EC2 which, is that like I don't get that, it's like
Oh, so when I say ET which, I'm try again. When I say ETC which, I mean I'm calling the function ETC with the argument which.
So, but I thought the function was for words.
You thought say that again, please.
The function was for ends.
It is, but ETC is a function that I am passing in as a parameter. So here's my initial call, and then I'm creating this anonymous function. That's going to be ETC. So you just have to be careful what's getting called where. Did that answer your question?
Yeah.
Go ahead.
Does OCaml like use the singular semicolon for functions that return something unlimited?
So OCaml just uses the semicolon anytime you want to execute a series of expressions and then only use the value of the last one. It doesn't really have, it doesn't really care what the expressions are. If you want to compute a series of things and then use the value of the last one, that's what the semicolon does. I hope that answers your
Yeah.
question. Go ahead.
So was ETC declared somewhere else or?
ETC is declared right here. It's an argument to for ints. So what's happening is when I call for ints, I'm creating this anonymous function, and then inside of for ints, ETC gets bound to that anonymous function, right? And then min gets bound to 1, and max gets bound to 10. So the point is that we can call functions with other functions in exactly the same way that we can call functions with any other value. Does that make sense? Other questions? Go ahead.
So, in the then, it's ECT, and then the series goes from which for into which plus one.
So it's calling ETC of which, and then ETC does whatever it wants to do with which. We don't care. For ints doesn't care. So we're going to forget about that, and then we're going to go on with for inting and with which plus 1. So that's, in effect, if this is like a loop, that's going to take us around the loop again with the next value.
Okay.
Other questions? Okay. Well, somebody had a good question. They said, can we nest these? So in an imperative language, we can nest for loops. So why could we nest these also? And the answer is we can. And that's actually one of the things I wanted to demonstrate. So So let's say we'll go like this, we'll say 4ints, and here's an anonymous function, and it takes left as its argument. And then inside here, we'll call 4ints again. There's a different anonymous function, and it takes right. And then, I don't know, let's imagine that there's some function here, p, which I don't know what it does. But this gets called with both left and right. Maybe p for print, maybe it prints both of them. Okay, that closes fun. And then here we will call 4ints with 1 through 10. And then here we'll call the outer 4ints with 1 through 10. So what does this do? Well, let's imagine p is printing left and right. So it would start out by going printing 1, 1, 1, 2, 1, 3, then 2, 1, 2, then it's gonna, I skipped a bunch of them, right? 2, 3, and I've skipped a bunch more. And eventually it would go to 10, 9, and 10, 10. Okay? So the idea is that if we have let's say two functions that both work by continuation passing, we can nest them, and we can send the results of one function to the other function, to another function that's mentioned inside the continuation. And so this is a lot like nested loops. This is like nested loops in another, in an imperative language, let's say. Okay, questions about that? Does that make sense? So again, there's no restriction on what the continuation can do. It can do pretty much whatever it wants, whatever we want our program to do. Okay, now, when we are using continuations to produce series of values like these are sometimes called generators. At least that's what I'm going to call them. And so a generator, for our purposes right now, let's say a generator is a function that produces a series of values through continuation passing. Okay? So in other words, it generates a series of values. And we can arrange then for the continuation to do whatever we want with those values. Okay, that's just terminology. Okay, where I am going with this is probably something that I'm not going to have time to finish today. But let's say I want to have a function, let's say I want a function that is, I'm going to call generate bools. Okay, and it's going to take a continuation and a number, and let's say an integer greater than or equal to 0, n. Okay, and I'm going to write this. I probably won't have time to write it today, but I will write it tomorrow. Okay, what do I want it to do? Well, what this will do is it will call our continuation, etc, with each possible list of n booleans, true or false. Okay, so for example, if I were to say generate bools, etc, and 2, and what happens is that etc is called with false, 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 true, true, false, and true, true. Okay? maybe in a different order. So let's say maybe not in that order. All right, so let's imagine that we don't actually care what the order is that these things are getting called. But we don't actually care what the order is that we're generating the lists in. But let's say we do care that all possible lists of Booleans get generated. Okay? Let's see if I can write this. Maybe I can. Okay, let's see what happens. So here's generate bools. And so it's taking etc and n as its arguments. Inside here is a helper, which I'm going to call generating. I could call it generating bools, but I'm not gonna. And it is taking here a list, which I'm going to call bools or booleans, and whatever the current value of n is. Okay. Now, I'm going to do a match on n. And what if n is 0? Well, what I'm going to want here is, okay, 0 just means, is going to mean, in this case, that I have finished generating my list. So n is actually going to be the number of elements that remain to be produced. And so if it's 0, I'm going to call the continuation on the Booleans that I have generated so far. Okay? Let's see. What if it's not 0? Okay, so I'm going to assume here that n is greater than or equal to 0. Right? Well, that's an underscore, so that will match any integer other than 0. So what do I want to do? Okay, if I want to generate all possible lists of Booleans, one possibility is that I want to stick false on the front of my list. So I'm going to cons false onto bools. And then I'm going to say n minus 1. Okay, because I have just added one Boolean, and so now I have one less step that I have to do. Okay, and I'll put a semicolon here because remember, all we care about is the value that the continuation is getting. We don't actually care what this function returns, at least not for the time being. Okay, what's the other possible way to generate a list of Booleans? Well, we could put true on the front of bools. And again here, n minus 1. Okay, and then this in matches our left. What do? We're going to start generating with an empty list and with n. Okay, and let's see. I have 15 seconds left, so I cannot fully explain how this works. But I will do that. I will talk about this next time.